I think it is Zoom it record one and then the sender. Did the create account here YouTube then the videos president that the record that's best coaching again. Yeah, the sender link here video in the record numbers. Yeah. So these are the Dovendi Tomekas Lazara Kavara last week. Okay. So I think rengaita example nti ine idowa ikoto resume say one of the method when I introduce last week. And then this to check iane pakene document. Oh, okay. Nakaka tizomuzari ending at the end of the jena na question na kubane pala results. Ano aba ni J ya 3x3. Ndikoto wasimeza musero no wana system ya ina variable za 4 Okay, let's use this one. I don't know, it's done already. Okay, let me check the one which is not done. These are examples. Bana tutorial sheet.
Atina ika laptop mani bondo.
Oh, okay. No, I'm not kaka and the shins are.
Elia do ndo bana tezi ya portion ndi nduri vona msindo do prepare ndo dzira guru ini zvabudu ndo vona mafastere.
Yeah.
Ndokona vone vachikwamba nane ubafu ndokona sana chichi practice anga mrava.
Okay. No, I'm not kaka the tomenga a question. Yeah,
Utote data vrone kai Vodacom vutonga sivunji don't todori ndi je net telecom ndi connect na iPhone uri kono va uri telecom i week ya mbora.
Oh, okay. I think kanji vanga shumisa data is lani za hour za Vodacom.
Okay.
I think it kind of 15 rand. So if you are okay. Arite question. In a quotation, a Gaussian elimination again. For sure, the main idea in this case is to get the value of x, of y, of z, and of w. So the question method on T1 or lower Gaussian, what I was last time. So the first thing we can do is to provide them the matrix equation for this system that we have there. So of which the matrix equation is going to be given by x, y, z, and then w. That is the vector. Then now let's get the components which we can have inside that matrix. So it's going to be 1 for coefficient of x, and then coefficient of y is -2, coefficient of Z is 1, and then coefficient for W is 0. Why is 0? Because we don't have W on equation number 1. So, and then again on the right hand side, we have 2, and then we do exactly the same thing for the second equation, which in this case is going to be 2. But on this equation, we don't have Y, which means coefficient for Y is 0, and then for Z is -1, for W is 2. Then we go to the last equation, which we're going to have 1 as coefficient for X and 2 for 1, and then 1 for Z, and then -3 for W. So this is the kind of equation we are having in this instance. And then on the right hand side, we have 2, we have 5, and then we have -4. So we have now converted the that. Oh, your cutter. Okay. I'll notate. No, I yantu ya Zoom haitukokoza material. Yeah. Okay, I'll cut. Yeah, exactly. Can you link it for it? Oh, okay, I'll notate.
Bondo.
Okay.
Yeah, no.
Okay, I continue. So that the we transformed our system of linear equations to a matrix equation. So now our matrix equation is given by 4 rows and 3 columns. So in other words, the size of this matrix is 4 by 3. So it's another important thing to take note of. In this case, the size of a matrix is very important. So it's 4 rows and 3 columns. So let's check. Oh, we have in this case is 3 rows because these are the rows. Row number 1, row number 2, row number 3, and then 4 columns. Column 1, column 2, column 3, and then column 4. So the size of this matrix is 3 by 4. So now you will see what will be the effect of a matrix with a size that is not a square. So it's going to be a square either if it is 3 by 3 or if it is 4 by 4. So, but now it's not a square matrix because it's 3 by 4. You will see the effect of that. Okay, then now let's see the target for solving this matrix is for us to obtain a 0 here and a 0 there and a 0 there. So, but now you will see that if we obtain the 3 zeros here, we'll be left with these two variables here, which are not going to be zero. And we'll see the effect of not getting a zero on one of these. So we were supposed to have a zero there, but we cannot get a zero because this is along the diagonal. So we don't have to get the zero on the diagonal. So we get the zero below or below the diagonals. So now let's first start with the zero on the 2 and then the 0 on the 1. This we can do at the same time. So but now we can first transform this into equation given by 1, -2, 1, 0, 2, 0, -1, 2, and then 1, 2, 1, -3. And then now instead of us writing the column vector there, we can then have the dots and write the vector we have on the right hand side. So you can write it this way. That is what is called the row echelon form. So when you replace this by dots, you have transformed this into what is called the row echelon form. So then now we can then implement the Gauss elimination into this equation. So the Gauss elimination is targeting for us to obtain the zeros on this position, the 0 on that position, and the 0 on that position. So it's a must that we must follow the order of getting the zeros here. You start by obtaining a 0 here, and then go further and obtain a 0 on here where we have 1, and then we then finish with the 0 on the 2 we have here. So now let's start with the 0. Yes.
Mr. That is that the rule? We must start with finding the zero on the two, and then followed by one, and that other two is the rule.
Yeah, it's the rule. You go by this like this. Otherwise, if you do it other way around, you will be finding 0 here. You will be able to get a 0. But when you go to this to get the 0 here, this 0 you obtained previously, you will see that it's gonna be another number of which it could be like you did not do anything. So that's why you need to follow order in this case, so that the 0 you obtained in the previous calculation is not over written by other value when you transform to get the zeros in other columns. So in this case, you need to follow the order. It's a rule. It's a rule that we need to follow the order so that we don't get the we don't override the zeros we obtained previously. So that is clear.
Yeah.
Okay, then now we start by obtaining a 0 here. So, and the good thing about this is that the zeros, which is along the same column, we can get them at the same time. So that cannot be a problem. So let's get a 0 here and a 0 there at the same time. So the equation for getting a 0 here, we need to use equation number 1, or we can use equation number 3, whichever equation is going to give us the answer. Let's use equation number 1 to obtain a 0 on row number 1 and then and row number 2 and row number 3. So we are going to have -2 row 1 plus row 2, and then this will give us new row 2. Why do we multiply with -2? Because we know if we multiply -2 with 1, we're going to get -2, and then -2 plus 2, it will give us a 0 that we are looking for. Therefore, this equation, it can do what we are expecting to do here for getting a 0 where we have a 2. And then let's do the same thing for 1. Can you tell me which equation can we manufacture to obtain a 0 here where we have 1?
I think let's just first write the new row for the new second row,
Okay.
so that it can be simple for me. But otherwise, I can still use the first row and the third row.
Yes, yes, yes. Yeah, very true. Okay, now
I
let's
can
first.
say
Yes,
row 1 minus row 3.
very true. Yeah, that's very true. It's row 1 minus row 1 minus row 3 will then obtain. But we write it
Yeah.
as negative because here we have to have positive at all time. So you play around with this, but here you must have a positive at all times. So it's negative row 1 and then plus row 2. And then from there you get, row 3, and then you'll get row 10. But as you said, let's first write a new row 2 and then we'll go to row 3. That is okay. So it means this, we're gonna do it at next D. Now let's see what we have. For row 1, we are not changing anything. It's 1, -2, 1, 0, and then 2. That is what is called row echelon form. This is in row echelon form. And then by using this new equation we have here, or the equation we develop, we're going to have a 0 there. But now, here we have a 0, but the 0 is going to be overridden by what? So it's going to be -2 times -2, which is 4 plus 0. Therefore, the new component there is going to be 4. And then we go to the other one. Here we're going to have -2 multiplied by 1. So it's -2 minus 1, which is -3. Okay, and then here we have -2 multiplied by 0, which is 0, plus 2, and that will give us a 2. And then on the other side, we have -2 into 2 is -4 plus 5, which gives us a 1. Is that okay?
Yeah, it's okay.
Okay.
I'm just confused why you are saying why when you say row, in order to find the new row 3, we must say minus row 1 plus row 3.
Yes.
Because if I can say row 1 minus row 3, I'm still going to get 0. I just want to give me clarification there.
The clarification is that we don't have to tamper with this sign, positive sign there.
Oh.
Yeah, because we are
Okay.
adding new rows. We have to add. We add new rows. So therefore, if we say row 1 minus row 3, it could have an effect on the signs for the new row. Row 3. So it might have an impact. So we rather write it in this way so that we don't tamper with this sign that we have there. So the positive sign there, we must not.
Oh, that's
Yes.
Oh, that's the rule. Is the rule for not changing the positive sign?
Yeah, we don't have to tamper with this positive sign.
All right, let's proceed.
Yes, exactly. Even though we know it's the same thing, but this sign we must not tamper with.
Okay.
Yeah. I think I will find another better explanation of why we need to keep the positive sign, so that maybe I have a proper clarification why we need to keep the positive sign instead of replacing with the negative sign.
All right, Mr. Ndo.
Yeah. And then we now have a new row 2, then row 3, we write it as it is. So it's 1, 2, 1, -3, and then -4. Then from there, we then introduce this negative R1 plus R3 must give us R3. Of which, if we do that, is going to transform row 3. So row 1 and row 2, we'll write them as they are. So it's 1, -2, 1, 0, 4, 0, -3, 2, and then 2, 1. So row 3 is the one which is being transformed here. So of which, if we transform row 3 by row 1, we're going to have -1 plus 1, which gives us a 0 that we are looking for. And then here we have negative into -2 is 2 plus 2, which gives us which gives us as 4. And then -1 plus 1, which gives us a 0. So negatives, in this case, is going to be a 0 minus 3, which gives us -3. And then -2 minus 4 is -6. So we now have the transformed row 3. So after having transformed row 3, I'm going to explain another important information here about getting this value here. Because we know here where we have 4, we need to get a 0. So then now, which equation are we supposed to use to get a 0 on row number 3? We need to use row number 2. We can't use row number 1, even though we know row number 1 can give us a 0 here. We don't use row number 1 because if we use row number 1, it's going to override the 0 we obtained previously. It's going to override this 0 we have down here. Therefore, we need to use row 3 because row 3 is having a 0 on this column. So if this is added with that, it's not going to make any changes. Is that clear?
Yeah, it's clear. It's clear.
Okay, then now we're going to have negative R2 plus R3, which gives us R3. So now let's see what we get after transforming. It's going to be 1, -2, 1, 0, and then 0, 4, -3, 2. And now we use that equation to transform equation number 3. This with that is going to give us an obvious 0. And then here we're going to get a 0 that we're looking for. And then here is going to be +3 plus 0, which is going to be 3. And then here -2 minus 3 is going to be -5. So here we have 2, 1. And then, but this is going to change. We're going to have -1 minus 6, which is -7. So we now have an equation with the zeros at the bottom. So these zeros, they are very critical. But now there's something which is going to happen on these equations. So I will mention it when we arrive there. As I've said, we now have 3 by 4, of which the previous time I told you that it's not proper that we find the values for x up to w for 3 by 4. Because at later stage, I'm going to tell you what do we call this kind of system, which is not having equal, the square matrix. So I will tell you the name for this. But here, you're going to see what is going to happen with it, because you can see we obtained a 0 here, but the other 2 components, they still have values. So what are we supposed to do with that? Okay, then now let's reverse back to this form, and then from there, we multiply the equations and see what we obtain. So I want to have 1, -2, 1, 0, 0, 4, -3, 2, and then 0, 0, 3, and -5. And then you will, okay, instead of having row echelon form, we then write the variable, these variables, which is x, y, z, and w. And then on the other side, we now have a vector of 2, 1, and -7. So let's multiply this and see. So the multiplication of a matrix and a vector, you multiply the row and a column, to generate the system of linear system. So now let's multiply the first row and the first column. So if you multiply the first row and the first column, it's going to give you x minus 2y plus z, and then w would be 0 in that case. Therefore, this would be equal to 0. And then the second equation is going to be 4y minus 3z Z plus 2W, which is equal to 0. And then the last equation is going to be 3Z minus 5W equal to 0. Are you with me?
Hello.
Yes.
Why are we saying equals to 0 whereas we have got 2, 1, and minus?
Oh, yeah. Hey, sorry, I forgot about that thing. We still have 2 here and we still have 1 there and then negative 7. Those are the vectors we have on the right hand side. Sorry about that. We still have the vectors on the side. Okay.
All right.
Yes. After doing that, we can then see that is unlike the previous example we have done before, wherein we can obtain the value of W or the value of Z. Here is not going to be the case because we have two variables. So it's not possible to get the value of Z or to get the value of W like in the previous question. So what we need to do here is to fix or to let one of these to be equal to W. Usually the last one is the one which we fix to be a certain value, maybe T in that case. So W is equal to T in this case. So therefore, we'll then have 3Z, we take this side, it will give us negative 7 plus 5T, which is a scalar quantity. So that will then be Z equal to negative 7 plus 5T all divided by 3. So then T in this case is the element of real number, which simply tells us that you can replace T with any value you like. So you can choose any value of T you will want to use in this case. You're going to get the answer that you are looking for. So now let's choose for T equal to 0 in this case. So if we choose for T equal to 0, we're going to have a Z which is equal to negative 7 over what? Over a 3. So we have Z which is equal to negative 7 over 3 and a W which is equal to 0 because we fixed W to be equal to 0. So we fix W to be equal to T, of which T is equal to 0. Therefore, W will be 0 and Z will be negative 7 over 3. So I would like to find out if you are with me up to here.
I'm with you. So I just want to know that W we can change it with P, with Z, with any alphabet.
Yeah, as long as this is a scalar quantity, like what I've defined here, T must be a scalar quantity.
Hey, now you're confusing. I'm confused when you say it must be a scalar quantity. How should I know that this alphabet is a scalar quantity?
Yes, because, okay, now let me get to the point. Because it's something which I wanted to explain at a later stage. This equation we are dealing with is linearly dependent. So it means you are not going to get a unique solution. You are not going to get a particular value for Z, for Y, for W, and for Z. You for X, for Y, for Z, and for W. You are not going to get a particular value. You can try to use a simultaneous equation here. It's not going to give you a specific answer or a specific value. So you are not having a unique solution in that equation. Why? Why that is the case? Because we have 4 unknowns and 3 equations. In grade 12, if we have such kind of situation, we say this equation is not solvable. Why? Because the number of equations are not the same as the number of unknowns.
Okay.
Yeah, but at tertiary level, then we have a way of dealing with that. We can be able to deal with a situation wherein the number of equations are not equal to the number of variables. So we call those equations linearly dependent. They depend to certain variable. So these equations, they depend to certain variable, of which the variable they depend to is variable T. So this variable T is a scalar quantity. When I say it's a scalar quantity, it means you can replace t with any value. You can replace it with -3, -2, -1, 0, 1, 2. It doesn't matter, whichever value. So if you fix W, you can then be able to get the value of X, Y, Z for that specific scalar quantity.
Okay. And Mr. Ndo, tell me,
Yes.
I must also write that T is the element of real number. If I use Z, I must say Z is element of real number. I must write it down.
Yeah, you must indicate that Z is the element of real number, but make sure the variable you use here is not the same with the variable which was used up here. For
Okay.
example, you pointed out the Z. The Z is already there.
Okay.
Yes, so we can use whichever variable. You can decide to use S instead of T. It's fine. So instead of T, we can use
Okay.
S. Yes, as long as that variable must not.
I think I'm with you.
Okay, yes, exactly. So already I clarified to you why we need to do this. It's because the equations we are dealing with is linearly dependent. I will cover this in detail. It's a very, very important aspect of this course. The linearly independent and linearly dependent. I will cover this aspect with you. But for now, I just went straight to the answer because you wanted to know why we decided to do this. But now I told you the reason why we decided to do that is because we're dealing with a system which is linearly dependent, of which you are going to come across with many systems and that are linearly dependent. Because at university level, we can be able to solve such kind of system. And this is the approach we take in order to solve such kind of system, of which we need to choose the value of S, which is the value of scalar quantity. And then if you choose the value of scalar quantity, then you can be able to get the value for the remaining variables, the variable X, the variable Y, and the variable Z. Let's do that and see what we obtain after fixing S equal to 0. We get W equal to 0 and we get Z equal to -7/3. What about Y? What do we get for Y? Y is going to be 4y minus 3, and then where we have Z is -7/3 plus 2Z is W is 0 equal to 1, and then we make 4y the sum of the formula. All the other things we can take them to the side. This that cancels each other, so we're having a +7. When we take it to the side, it's going to be -6. Therefore, y will be equal to -6/4, which is the same as -3/2. So then after obtaining the y, you can then obtain the x, which is going to be given by x equal to, you take other things to the side. So it's going to be 2 into -3/2 minus z, of which we find to be -7/3. So we can use calculator to see what we obtained here. So this is -3 plus 7/3, of which it will be 16/3, I think. But you can verify with the calculator. So by doing so, you now have the value of x, y, z, and w. But these values are for when s is equal to 0. One may decide to do for s equal to 1 or for s equal to 10. No one can mark you wrong if you decide to do so, because this w or the s is a scalar quantity which you can replace with any value. As long as that value is within the range of real number, you're gonna get the correct answer that you are looking
Okay. So, Mr. Ndo,
Yes.
Mr. Ndo, are you still with me?
Yes, I can hear you.
I think I'm clear. I'm
Oh,
clear now
yeah.
on this issue, on this question. Yeah.
Okay. Yeah.
I don't have
Otherwise,
any questions, Mr. Ndo.
yeah. Otherwise, We are still going to cover the aspect of linearly dependent at later stage under this course.
Okay.
Okay, can we go to the second topic of the course?
Yeah.
Okay. Of which is about okay, the matrix and matrix operation. The second topic here is what is called matrices and matrix operation. So the operations we are going to implement here are the same with the operations we do for real numbers. For example, the positive sign, I mean the operation of addition, we use it with real numbers like 2 plus 2 will give us a 4. So we're still going to implement that. And then the other one, it's a negative. We're going to implement the negative. And then the two operations which differ here is the division and the multiplication. So let me cycle this because that they're a bit different. With matrices, we don't apply them as they are, like when we have the real number. So you can't say 2 times 2 and then you obtain a 4. So we don't do it like this if we have a matrices. So now let me quickly go to explain that. We can start with addition. Addition. Hello.
You know, the video on my side is moving like I don't know what's happening, but I can hear you speaking, but I cannot see you demonstrating on the whiteboard. The screen is moving.
Oh, okay. Let me find out what's the problem.
I don't know if it's the issue of the network, but I can hear you nicely. But on my side, you are not moving. You are just fixed.
Okay. Let me find out what might be the problem.
Yeah.
How about now?
Okay. You know. Let me try what.
Yeah.
Let me try to join the meeting again.
Yeah, you can rejoin the meeting.
Okay, Mr. Ndo.
Hello?
Yeah, I think it's fine now.
It's fine now. Okay. So I was still explaining here about the operations that in matrices, operations which apply the same way we are solving when we are solving the real numbers is the operation of addition and subtraction. So the operation of division and multiplication is a bit different in this case. So we don't apply them the same way when we are multiplying the two real numbers. For example, if we are multiplying the two real numbers, we're going to have 2 multiplied by 2 and we get a 4. So it's not the case for matrices. So now let me start by explaining the addition matrix operation. So I'll explain by using a 2 by 2 because it's the same with when we're having a matrix of a different size. But when we go to division, I'm going to explain for 2 by 2 and also for 3 by 3 because they don't use the same approach. So let's start with the addition. So for the addition, let's say we're using a 2 by 2, which is given by A, B, C, D. And we want to add it with another a matrix which is given by C, D. Okay, let's use E, F, and G, H. So now let's say we want to add these two matrix. Let's say we want to add these two matrix. So if we add these two, we're going to have A plus E, which will be A plus E, and then the other one is going to be B plus F, and then the other one is going to be C plus G, and then the last one will be D plus H. So that is what we can do for what? For addition. And then for subtraction, they are a little bit the same. So it's going to be subtraction. It's going to be A, B, C, D minus into E, F, G, H, of which this will be A minus E, B minus F, C minus G, D minus H. So for this operation, there are no much difference that you are going to encounter. They are the same. So for the addition and for the subtraction, you can see it's the same way we do when we have the real numbers. So I believe you understood the two operations I've introduced just now.
Yeah, I'm with you. I would just ask if you can have an example of question so that we can work under addition and subtraction instead of
Okay.
variables.
Yes, exactly. Let's have an example. Let's say we want to add adding and subtracting. Let's say we have a matrix. Let me take a matrix which are given here. Okay. Yeah, let's say we want to add these two matrix. So we're given a matrix A of 0, 3, 1, 4, and a matrix B, which is given by 1, -4, 0, 1. Let's say we want to apply the operation of addition and subtraction on these two matrices. So we're going to have A plus B, which will be 0, 3, 1, 4, and then plus 1, -4, 0, 1. So now with this, it means you're going to add 0 and 1. 0 plus 1, it gives you the first component there, which is 1. How are we going to get the second component? The second component is going to be 1 plus -4, of which is going to give us -1. And then the third component is going to be 1 plus 0, which is 1. So 4 plus 1, which is what? which is 5. So that is how you get the addition of A and B for the two matrices. And then for the subtraction, A minus B. A minus B is 0,314 minus 1,401, of which is going to be 0 minus 1 is -1. 3 minus -4, so it's going to be 7. And then 1 minus 0 is going to be 1. 1 minus 1 is going to be 0. And that is what you get under the subtraction. But A minus B is not the same as B minus A. It's another important aspect which we have to take note of, that A minus B is not the same as B minus A, but A plus B is the same as B plus A. So that does not affect any weight. Or is for the multiplication. Is for the multiplication where AB is not the same as BA. So, but A minus B is the same as B minus A. Sorry about this. You must take note of this. It's only for the multiplication where it's not the same. So A minus B is the same as B minus A. A plus B is the same as B plus A. So that is fine with regard to that. So those are the two operations which they are not affected. They are the same with the real numbers. But as I've said, the next two operations which I'm going to introduce, they are the ones which have problem. So the division and the multiplication. So those are the two operations which have problem, the division and a multiplication. So we need to focus more on these two operations. Are we all together?
Yeah, we are together.
Okay, then now let me quickly go to those operations. So the first one, we will start with the multiplication. The division is the worst one. So let's start with the multiplication. Multiplication operation. So with this one, we have multiplication sign, of which we are not even required to write it. So we just have to have the two matrices which are multiplying to each other, like that. So we don't write any sign in between. So, but we know these two matrices, they are multiplying to each other. So then now the question is, how do you get the first component, the second component, the third component, and the fourth component of this? The very first thing which you need to do is to check the size for this, because you don't multiply, even to add and subtract, you don't add or subtract the matrices of a different size. They must have the same size. So you need to check the size. The size of this matrix is 2 by 2. And then for this one, it's also 2 by 2. It's a must that the components at the middle of the two matrices, they must be the same. That is a must. Otherwise, if they're not the same, it means the two matrices cannot be multiplied to each other. So now, if they are the same, it simply guides you of what will be the size of the matrix you're going to obtain here. So the size of the matrix you're going to get by multiplying the two is going to be given by 2 multiplied by 2 is these numbers we have here. So this must be the same, and then this tells you about the size of the matrix you're going to get after multiplying these two. Are we all together?
Yeah, we're together.
Okay, then now let me tell you the method we need to use to multiply the multiplication operation of the matrices. In order for us to obtain the first component, we need to multiply the first row with the first column in order for us to obtain the first column. So let's do that and see. You multiply A and E, so it's going to give you AE. And and then you add with multiplication of B and G. So it's gonna be the first component. AE plus BG, it gives you the first component. Now, how do you obtain the second component? You multiply the first row and the second column, of which if you multiply A with F, you obtain AF, and then B with H, will obtain plus BH. So to obtain the third component, you multiply the second row with the first column, of which is going to be CE plus DG. And then the last one, you multiply the second row with the second column, of which is going to be CF plus DH. So this is how you multiply the two matrices. So this is how you multiply the two matrices. You need to follow this approach that we have taken. And you can see that the size for this is 2 by 2, of which we were guided by what we have here. Are we together?
Yes. Can you quickly do it again, or just explain again when you do the multiplication as a belief?
Okay. So the multiplication of the matrices, we get it in this way. In order for us to get the first component, this is the first component, second component, third component, fourth component. In order for us to get the first component, we need to multiply the first row and the first column. So if we multiply the first row and the first column, it means it's going to be A multiplied by E plus B multiplied by G, of which that will give you the first component. In order for us to obtain the second component, we need to multiply the first row and the second column, of which if you multiply the first row and the second column, is going to be AF plus BH. This is what we have there. In order for us to obtain the third component, we are going to get it by multiplying the second row and the first column, of which if you multiply the second row and the first column, is going to give you CE multiplied by DG. That will give you the third component. And then the last component in that case, you're going to get it by multiplying the second row and the second column. So if you multiply the second row and the second column, it's going to give you a CF plus DH, of which is what we have there.
All right, now I'm clear.
Okay, can we do an example so that you see how we do this multiplication?
Yeah.
By having the values. Okay, let's say we are multiplying multiplication of A and B. So multiplication of A and B is going to be given by 0, 3, 1, 4. We don't put the multiplication in between. So we'll then have 1, negative 4, 0, 1. So if we multiply these two, we then follow this procedure. Let's follow that procedure and see what you get. So it's going to be the first row and the first column, of which if you multiply first row and first column, you're going to get a 0. Because it's going to be 0 multiplied by 1, which is 0, plus 3 multiplied by 0, which is 0. 0 plus 0, it gives you a 0. And then to get a second component, you multiply first row, second column. This multiply with that is 0, this with that is going to give you a 3. And then to get the third, you multiply this with that, so it's going to be 1 plus 0, of which is 1. This with that is going to be negative 4, plus 4, which gives you a 0. That is what you have there.
Wow, okay.
Yes. So you will now have the multiplication of the two matrix. So it's the same approach you use when you are multiplying the 3 by 3, the 4 by 4, and the 5 by 5. The only difference, it comes when we are having the operation of the division. So this works differently with all the other operations I've explained before. So let me do that last operation just now. So I'll do for 2 by 2, and then for 3 by 3. I don't know if I should cover that for you now, because it requires a lot of things. For 2 by 2 division operation, for 2 by 2 matrices or matrix. So now let's say we are given a matrix A, given as A, B, C, D. So, and we want to divide this matrix. We want to divide matrix. Okay, we're given A and matrix B of E, F, G, H. So I believe you may say the division of A with B is going to be given by something like that. And you then divide A by E, B by F. No, it doesn't work like that with this one. So this is what you're supposed to do. The very first thing you will need to do is to transform this. You find the inverse of B. Because if you find the inverse of B, it will simply mean that instead of writing A over B, you will then have A multiplied by the inverse of B, which is the same as A divided by B. So now the issue is when you are finding the inverse of B, then how are we supposed to find the inverse of B? That is the critical part about this. So let's first find the inverse of B. So I'm going to tell you of how you're supposed to find the inverse of B. So you find the inverse of B by saying 1 divided by EH minus GH into, and then here you swap the position. Where you have E, you write H. Where you have H, you write E. And then on the, these are on the diagonals. So the diagonal, you swap the positions. And all the components on the diagonal, you then put the negatives like this. This is how you get the inverse. What is the first thing you do? You have 1 divided by the multiplication of the main diagonal as by subtraction of the off diagonal. So it will give you that fraction. And then from there, you go to the diagonal, you swap the positions of the diagonal, you put the negatives on the 9 diagonals. That will give you the inverse of B. Is that clear?
Yeah, it's clear. It means that one is a little formula, né?
Yeah. This is how you find the inverse. It's how you find the inverse of B.
Okay.
Yes. Remember, our task is for introducing the operations for dividing A by B, of which is not possible to divide it in this way. Therefore, you need to write this as A multiplied by inverse of B. So you can even see the way I'm writing the multiplication here. It's not like multiplied by like this. So you need to write sort of like star, you see? Okay. So this is how you get the B. And after obtaining the B, you can then multiply. You can then multiply the A and the inverse of B to obtain the A divided by B. And see how is our B, inverse of B. This is our inverse of B. So it means 1 over EH minus GH must be multiplied with all the components we have here. And then after having that, you then have the inverse of B, of which you must then multiply with A to get A divided by B. So let's do that with an example so that you can see how we get to the division of A and B of the matrix. We're gonna use the same that we have there. So the division of matrices. So we have matrix A and B, of which the first thing we can do is to obtain the inverse of B. So how do we obtain the inverse of B? You multiply 1 with 1, which will give you 1. You subtract by the multiplication of the off diagonal, of which in this case is going to give us a 0. Then the next step, what do? You swap the positions of the diagonal, of which if you swap in this case, you're going to obtain 1 and 1 because it's the same thing. And then the next thing you do. Yes.
Can you please go a little bit back when you say 1 over 1 minus 0? How did you obtain 1 minus 0 quickly?
Okay, so in this case, we are using this formula we have here. So it's 1 divided by the multiplication of the diagonal, which in this case is 1 multiplied by 1, which gives us a 1, and you subtract by the off diagonal, of which you are going to subtract by 0 multiplied by -4, which will be 0. So that's why we have 1 from the diagonal minus 0 from the off diagonal.
Okay.
And then after having that, you then swap the position of the diagonal. So fortunately, here we have ones. Even when we swap, is the same thing. So then, but the ones of the off diagonal, you need to change the sign. If it was positive, it changes to be negative. If it was negative, it changes to be positive, because we multiply everything by negative there. So it's going to be 4 here and a 0 there. 0 does not change the sign. So again, here we are fortunate because 1 divided by 1 is the same. So therefore, the inverse of B is going to be 1, 4, 0, and 1. Of which, in order for us to obtain A divided by B, is the same as saying A multiplied by the inverse of B. And we are given the A here as 0, 3, 1, 4, and the B, which is 1, 4, 0, 1. So now when you multiply these two, is this multiplied by that, which gives you a 0, and then this multiplied by that, which gives you a 3, and then this multiplied by that, which gives you a 1, and this multiplied by that, which gives you an 8. So that is the multiplication.
Okay, Mr. Ndo. Yeah, I think the concentration is needed.
Yeah. So that's why I think I don't have to introduce for the 3 by 3, because hey, that one is too much. Yeah, it's too much. For 3 by 3, it needs a day. So we need to have the whole day for covering the 3 by 3. Otherwise, I think if we covered up to 2 by 2, it's enough for the day.
Okay.
Yeah. So let me not give you a lot of information at the same time. So it's enough up to this one. So the next lesson is gonna be for 3 by 3, and then we then get to the determinant. Of which determinant, if you notice, we have covered it somewhere here for 2 by 2, but for 3 by 3, I will introduce it to you in the next lesson. So in the meantime, let's focus on what we have covered. So the addition, the subtraction, the multiplication, and the division of 2 by 2.
Yeah, that's the new thing that we did today. So which means myself, I'm going to work on them tomorrow on Wednesday up until but Pella, we're going to meet on Thursday, right?
Yeah, but even when you have a question any day, you can let me know. I will assist you with that question.
No, it's fine. You know what are my plans?
Yes.
Let's work following the guideline on the tutorial, like on the stuff that I gave to you.
Yes.
like I gave you the guide.
Exactly.
That guide is indicating topic 1, unit topic 2, topic 3 up to topic 4. So I think you must do them logic from the first topic, second topic, third topic, fourth topic, up until we finish the study guide.
Yeah, very true. It's what I'm thinking of doing as well. Because you remember the first time we started with the gas elimination, which is the first topic, and then now we're doing matrices and matrix operation, and then the next is
Yeah.
going to be we are following the guideline. So I will stick to
Yeah, exactly. So I want us, when we finish the unit 1,
yes.
I want us to work on that first assignment. Like the whole lesson is gonna be focused. Is gonna focus on the assignment. That assignment is having 20 questions, ne?
Okay.
Which are multiple choices. So it means we're gonna get a day where we'll be answering those questions, working on the whiteboard with me, so that I can see how are we gonna find the solution for those multiple choices questions.
No problem. No problem. There's no problem at all
Yeah,
with regard to that.
yeah. So in the meantime, Sando, please make sure that you send me the baking details on WhatsApp, ne?
Okay, I'll do so. Okay. Yeah, otherwise let's meet again on Thursday.
I will recharge you. I will recharge you on
Okay, okay, no problem.
Mr. Ndo.
Hello?
Ndanditseva ndizova recharge anga Saturday yatiri.
Okay, okay, no, hauna kakati.
Lorara mwana mianga. Utusana ndotusana mwana mianga usadzivi chitu. Utohumbira ponodziva, auna unodziva zvose.
Ndingoyoperawe. Nandiona zvinji zvine ndikadhitiyo kuda.
Tabukuma, I know. Ndariwa dhuva namusi ne ridopana anga labuna.
Okay, hauna kakati. Da.